Hello, everyone. Thank you very much for joining today's pitching session on the screening platform and biomarkers for prediction and prevention of diseases of unmet public health need. We have a packed agenda today with 19 presentations. This is the list of pitchers, presenters for today's session. And just a quick reminder on how you can contact the pitchers. So you can access their information directly on the top navigation menu under Pitchers Call Session 3 and just search for their name. Or if you want the full list per session, just go to the agenda and you have the list there of their presentations together with the pitchers' names. And below you have the list of speakers for today's session. And so without further ado, we'll start our presentations. I would like to ask Professor Oscar.
Thank you, and good day to all. And I'm here today to introduce you and to invite you to join our project, our dream, which is to get a grip on NASH. Next slide. NASH and NAFLD are diseases of the liver in which fat gradually accumulates. It's not really related with alcohol intake, but more with cardiometabolic risk factors, obesity. And these are diseases that increase the risk of developing cirrhosis, cancer, also cardiovascular diseases, diabetes, and death. What we have seen in the last decades with the changes in lifestyle, the deterioration in lifestyle has meant that people are suffering from these conditions every time more. And it is clear that in the future, the impact of the diseases could further increase. Nevertheless, we don't have proper diagnostic, preventive, or treatment measures for these diseases, and we need to improve the way that we understand these conditions. Next slide. Therefore, the main objective of grip on NASH is understanding and improving the way that we prevent, the way that we diagnose, and the way that we treat these conditions, NASH and NAFLD, by understanding better how the disease occurs, how can we diagnose it with perhaps better biomarkers, and how can we improve the pathways to be able to develop better treatment strategies, because right now the cornerstone of treatment is lifestyle, and lifestyle is very difficult to change. Next slide. And we will aim to achieve this by using information from 10,000 people from 10 different countries in Europe so that we can understand the particularities in each specific geographical location. This will be 10,000 people identified at the primary care level with a higher risk of developing these conditions, having obesity or hypertension, for example. They will follow a collection of information, of samples, but also treatment with lifestyle, and we will be evaluating the condition of the liver health throughout this process. Next slide. And for this, we have put together a team, which should I say the A team of great experts in the fields of gastrointestinal health, liver health, but also public health and epidemiology, because we know and we realize that this is an important unmet public health need. Next slide. And in that regard, we would like to identify partners that will be interested in collaborating with us, partners that could be perhaps willing to investigate better how to treat this condition or how to diagnose it, or that have perhaps information on biomarkers or want to improve by the use of biomarkers the diagnosis of the condition so that we can prevent it or we can treat it at an earlier stage. Also, companies with able to deal with big data, because we will be dealing with big data, are very much invited to join. Next slide.
So that's your last slide, Oscar.
And with this last slide, I would just like to invite you all to join the A team and to join our dream and to finally get a grip on NASH. So thank you very much for your time.
Thank you very much, Oscar, for your presentation. I would like to ask the next speaker, Alessandra, to join our virtual stage.
Hi all. This is Alessandra Rinieri from the University of Siena. I'm medical geneticist, professor of medical genetics at the university, and the director of the clinical unit at the hospital. Next. So we want to cover these needs related to the fact that the many large biobanks have a poor clinical description and the patient's contact is not available. We want to work in this IHI project since for reaching the goal of this call, it is necessary a joint effort from the academies like us and the companies. And we have also developed for a common disorder that is COVID-19, a new model called post-Mendelian, in which we can interpret by which we can interpret the DNA sequencing at the genomic level, combining the common variability and the rare variability. By this model, we are able to predict the severity of this disorder with an accuracy of about 80% right now, and the accuracy is improving. And we can apply this model to any kind of human disorder. Next slide. So our main activities for this project would be to refine this model in order to increase the accuracy and to apply this model to any kind of disorders, human disorders. We will use our internal biobank and registries and in Siena, and not only, because I am also the head of the NIG, a network for Italian genomes. So this is a network of several institutes in Italy who have collected genetic data at the exome and genomic level of any kind of human disorders. Next slide. So, our expertise is both at the clinical, I'm a medical doctor, and at the molecular level, namely the DNA level, both in rare and common disease, ranging from a very wide range of disorders, covering all medical specialties, and including the acute and long COVID. Here you have some numbers of our internal cohort of samples and electronic health records collected since 50 years. And on the bottom of the slide, you have also the paper in which the post-Mendelian model is published. We have used a machine learning method in order to use the common variability, which normal is interpreted by the duos, the classical duo studies, and we have combined them with the rare variants. Next. So, we are seeking for, of course, also a research institute to collaborate with the research institute, and also specifically with companies, both SME and large companies who want to place the post-Mendelian model in the market and using it for prediction and prevention of human disorder. Thank you so much.
Thank you very much, Alessandra. I'd like to ask now the next speaker, Jan Bombach.
Yeah, that's me, Jan Bombach, Bombach, Jan Bombach, whatever you prefer. I'm the director of the Institute for Computational Systems Biology in Hamburg, and what we do is nowadays dubbed into systems medicine, mechanotyping, and so on. So we are like specialized on all kinds of computational techniques like AI, machine learning, you name it, for the identification of disease mechanisms specifically, and for the identification of mechanistic markers. So we want to detect molecular markers that help us to stratify patients based on their mechanotypes rather than symptomatically. Next slide, please. So one big problem is, of course, GDPR, privacy, and so on, data sharing and such, despite all the other problems that go with the identification of complex markers in high-dimensional data. Next slide, please. Yes. So what we develop is federated platforms. So I'm coordinating a big project called Feature Cloud, financed by Horizon 2020. And what we do there is providing apps for training AIs in a federated fashion, meaning privacy preserving. We enhance it with other privacy enhancing technologies like homomorphic encryption or secure multi-party computation. So key difference to others is that the data can remain distributed. Next slide, please. So in current medicine, one big roadblock is that the AIs would need to be trained centralized. So we have seen it in a presentation by Oscar Franco, for example, right? So the data is gathered across Europe, and then it cannot be centralized. So that's why all samples need to be sent somewhere and so on. People need to trust each other, patient consent and so on is a problem. So centralizing data is a problem. Which hampers essentially the computational, statistical, machine learning, AI-based analysis of such data. Next slide, please. In order to generate better hypotheses, what we are developing and what we also have developed actually, and what we are like improving now, is a federated database network. So you just register the existence of data. You don't actually copy it into a cloud. And then we have federated machine learning apps that allow to like essentially bring the AI trainer to the data instead of bringing the data into a central cloud for AI training. And then based on these models, we can then develop MDX tools, medical diagnostics tools that can be applied, for example, in screening. Next slide, please. So I already mentioned Feature Cloud. That is one of the our lighthouse projects. You find it at featurecloud.ai. We are a large group of people with different expertise, covering everything from ethics, legal assessment, cyber security, and so on, all the way down to omics profiling and machine learning. That's what I'm particularly strong in. So next slide, please. If you go to featurecloud.ai, you will find an app store. We have more than 60 apps already available for some very generic, like deep learning, a federated random forest, a federated ridge regression, and survival analysis apps for Kaplan-Meier plot generation, and so on, all privacy preserving. Some of them are already tailored towards specific data, gene expression data, or variation polling, genetics data, and so on, all working fully federated. Many of them have been published already, and we very recently, last week, received a big Horizon Europe grant on microbiome profiling of stool samples to detect colorectal cancer early and, yeah, let's say minimally / non-invasively. Yeah, next slide, please. And yeah, what we are looking for is essentially a consortium that would need such technology, right? Of course, like traditional mechanotyping tools like network enrichment and so on. However, we specifically like to offer our services with respect to federated data analysis. When the data is gathered, distributed across Europe in different locations for many reasons, maybe privacy or because the data is sensitive to pharma companies, for example. Well, like you don't want to share the raw data, but you still want to learn predictive models. So that is what we are particularly good at. That's what we have a lot of experience in, and that's why we have already working and published tools. And we're looking for consortia who would have a need for such kind of technology. Thank you very much. That's pretty much it. You can find us at cozy.bio, right? So that's my lab URL. So we're about 60 researchers here, and depending on what exactly you need.
Thank you very much.
Find us there.
Thank you, Jan. Thank you very much for your presentation. I would like then to ask Svetlana to our virtual stage, please.
Thank you very much. Good morning, everyone. And thank you, Jan, for laying out the theoretical background of federated learning, which makes my job presenting much easier. My name is Svetlana Sorodina. I represent Kane. We work on the data valuation and evaluation technology with a specific focus on the distributed healthcare and research settings and on bias mitigation and ethics assessment and health AI. On this slide, you have a few ways to contact me in addition to the IHI platform. I also copied them in the chat. I do encourage you to connect and explore ideas together now or in the future. Our company is an SME, now headquartered in the United Kingdom, but we're operating as a Ukrainian company with a large part of our team continue being based there. Next slide, please. Thank you. Our main objective is ensuring ethical compliance of algorithms and data quality in AI-assisted decision-making, which is increasingly important and essential even to mitigate the regulatory risks and ensure high-quality, reliable models. Next slide, please. Our solution operates in federated learning architecture and aims to integrate into clinical research and operational workflows with human-centered decision-making support at its core. Next slide, please. We are currently working on a proof of concept supported by Horizon Europe grant in neurostimulation, and we're developing a migraine biomarker platform, applying our technology, and we're now looking to expand and scale up our work there. Next slide, please. From our side, we offer technology and technical expertise via the existing network. We currently working as a partner in 2 Horizon Europe projects. In addition to one I mentioned, we're also looking at more technical fundamental work in AI for communication networks, especially for healthcare. We produce high quality deliverables, including data system development, but also coordinating academic publications, for example. And we have academic research facilities at King's College London. Next slide, please. And we want to connect with people and organizations who are as passionate as we are in applying data technologies for healthier, longer lives. Thank you very much for your attention. Thank you, organizers.
Thank you very much, Svetlana. And just as a reminder, please use our platform if you want to connect with the presenters and the speakers. So there's the tab on the top and the pictures, and you can find all the pictures there for the sessions. So I'd like to call on the next presenter to the stage, Oliver.
Yes, hello everybody. Thank you. So I want to show you in Engage really the challenge of liver cancer screening and outcome prediction, and really building on top of what Oscar Franco has already showed you in the very first pitch. So next slide, please. As we have seen already, liver cancer or liver disease is a challenge, but so NAFLD and NASH, as presented before, is just a precancerous phase of liver disease, and we see that many of those patients are progressing to liver cancer. The challenge is that really the mortality and survival, so mortality of liver cancer patients is high, survival rates is constantly low since decades. And there are really a lot of omnipresent risk factors. Alcohol and hepatitis virus infection, of course, is well known, but as indicated by Oscar already, really also unhealthy lifestyle, unhealthy diet really is increasing those risk factors tremendously. Because of that, really many experts expect a huge incidence of new liver cancer patients in the future. So we believe that this is really a high unmet public health need where better screening and surveillance is needed. Next slide, please. So the objective of Engage is really to overcome the presentation of patients with NAFLD cirrhosis, which is the precancerous phase of primary liver cancer, and then hepatocellular cancer in Europe. We want to do that in 3 steps. So our objectives is on the one hand side, of course, to select the patients that are of highest risk, because you have seen the risk population is so large that it's very difficult to really screen all of them. So therefore, a proper selection of the patients is needed. So that's step 1. And of course, the step 2 would be the detection of liver cancer as early as possible. And for that, of course, we want to look into multiparametric diagnostic and prognostic biomarkers. And finally, of course, once liver cancer is detected, it's about how can we navigate the journey of the cancer patients appropriately, such that really better outcomes can be achieved. Next slide, please. So the activities, what we are planning in this project is really a clinical study with 3 arms, with blood, stool, and imaging data from patients at risk for liver cancer. And we will have a cohort more on the metabolic disease NASH population. A second arm looking into cirrhosis or cirrhotic patients, and a third cohort, a patient cohort that already has primary liver cancer. We want to develop and test novel and existing biomarker panels based on genomic data, methylation and proteomic panels. But there's also, of course, MR and ultrasound imaging and elastography and AI-driven combinations thereof. And finally, of course, we believe that really education, both of patients and professionals, is important. So we want to implement a patient engagement platform and data warehouse which consolidates the data and really provides then educational material to the patients. Next slide, please. So what we have so far in our consortium, and we are also discussing already with Oscar, is really a lot of clinical expertise. So we are in contact with the leading or with some of the leading clinics for liver cancer in Europe, the Barcelona clinic and the Bouchon Hospital in Paris, which provide the clinical expertise, trial management, patient access, but also have very deep connections into the guideline committees in order to also influence that. We have Universal DX on board as an innovative biotech company looking into genomic signatures of cancer in blood, and we from Siemens Healthineers bring in imaging and serum tests to risk stratify patients. But of course, we are very open, and that's on the next slide, for more partners, particularly at the moment. And I really want to stress that we don't have achieved the required in-kind contribution that would be needed in order to start such a program yet. So we are particularly still looking for large companies from pharma, but also from other medtech companies who are interested in biomarker research to tackle liver disease, both on the NASH and the cancer side for longitudinal disease management. Same, of course, for IT companies who are interested to bring in data warehouse technology and patient engagement platforms, as well as insurance companies who are interested to drive population health programs and prevention programs. Of course, we are also looking for innovative research institutes and SMEs, particularly also in the domain of health economical modeling. But as stressed before, really it's really essential at the moment to bring in more partners that can bring in-kind contributions to the program.
Thank you very much, Oliver. Thank you, Oliver, for your presentation. I'd like to call now Ana Solana Sanchez.
Thank you. So my name is Ana Beatriz Solana. I am from GE Healthcare, and today I'm presenting PredictTom on behalf of a greater consortium. We are aiming here to develop an AI-driven screening platform for early diagnosis of neurodegenerative diseases. Next slide, please. Neurodegenerative diseases affect millions of people in the whole world and even millions in Europe. And there is also increasing numbers due to the aging of the population. But it is not only the prevalence, what it is important is that the neurodegenerative diseases are the #1 leading cause of poor health and disability. There is also a huge socioeconomic impact due to that, and the health and the social costs are larger than cancer and chronic heart disease due to neurodegenerative diseases. Traditional diagnosis offers come too late. So for example, in the graph, we are showing how the early symptoms of dementia are coming too late, far later than the onset of the disease marked by the amyloid plaques and the tau tangles. Early diagnosis is key to improve patient management and also to decelerate the prognosis of the disease increasing some lifestyle or medication. And it is also important to develop further disease-modifying treatments. We have already some good markers that can allow early diagnosis of these diseases, but they are often not so accessible due to cost or complexity. And we have also a lot of data available, but it is normally not usable because of lack of accessibility, of connectivity, and also lack of AI tools that are joining the dots. So here in Predicom, we are aiming to develop a scalable AI platform to connect existing biomarkers, data banks, and the prognosis and outcome of the disease, and collect new biomarkers. Next slide, please. We are showing here graphically how we would envision that scalable AI platform. So we are seeing how we would collect, analyze, and explore existing and new biomarkers from simple home health devices to complex pharma or imaging tools, and how we aim to develop AI tools for better diagnosis, disease prediction, therapy monitoring, therapy definition or prediction. We are aiming to have a patient-centered tool that some of the main users will be the end users, but also the primary care, the specialized centers, and even the health system. We are planning to design a cohort screening study aiming at the general population, and the participant we alter in that panel that we are seeing in that slides. Next slide, please. This is another of the representations of that panel, how the data flow is aimed to move into that platform. So starting from home. And I would like to just point out that we are aiming that some of the biomarkers that we are normally seeing at the specialized center, we are aiming to bring them a little bit closer to the general doctor, and developing some new ones like black exosome biomarkers, or bringing brain imaging closer. Also, the AI tools are going to help us that this platform is going to moving forward, and we are bringing these things along the time closer. Next slide, please. We are already a group of partners, both from the technological group and the pharma groups, including also leading research and clinical sites, together with some associations, patient and disease association. And I'm listing on the right side of the potential partners. I think we are closer to get our in-kind that we would need, as Oliver has pointed out. We would still miss a little bit of the in-kind, so that some big companies that are allowed to provide some in-kind, above all from the pharma part, would be appreciated, but also some regulatory ethics. But also, as Jan has commented, this is kind of a big issue with these kind of AI platforms. So if you are stimulated by this project and you would like to connect and talk to us, we will be very happy to connect with you. Next slide, please. You can connect us through the IHI. Thank you very much.
Thank you very much, Anna, for your presentation. I'd like to give the floor now to Lucia.
Thanks for the opportunity. I am Lucia Ruggeri, and I'm acting and speaking on behalf of EPTRI, the European Pediatric Translational Research Infrastructure. You can see here in the slide contacts. Next slide, please. So first of all, why including children in a proposal dealing with diseases, prevention, and unmet public health needs? This is because pediatric population might show unique vulnerabilities and disorders since early childhood, and you can see here in the slide a non-exhaustive list. And of course, the availabilities of biomarkers could also contribute to the faster characterization of drug efficacy and safety in this population. And on the other side, there are a series of challenges hampering the adoption of biomarkers in pediatric subsets. And these are referred to logistic, methodological, scientific, and economic challenges. Thanks. Next, please. So, how EPTRI could contribute, very few words about it. It's a pan-European initiative delivering services to boost pediatric research ecosystem and improve development of new medicine. It is organized as a distributed research infrastructure with a central hub and several spokes represented by thematic research platforms according to their fields of expertise and national nodes according to their location. As biomarkers is one of the EPTRI scientific domain, we would like to actively collaborate with consortia to implement research activities to demonstrate the value of biomarker as a tool for prognostic purposes for prediction of drug efficacy and safety in the pediatric subset. Next, please. So beside the specific domain of pediatric biomarkers and biosamples, EPTRI operates in other 4 scientific areas, thanks to the contribution of research services working and delivering, research units working and delivering services in these areas. And you can see here on this slide. Next, please. So, in detail, the thematic research platform on pediatric biomarkers and biosamples can support activities related to biomarkers identification and validation, including about 30 research units from 14 European and non-European countries, working in a very wide area, in very different therapeutic areas. And so matching the topics of the IHI call together with the services that EPTRI could deliver, we have identified 4 main areas of potential collaboration. So dealing with scientific and methodological aspects, networking, bioinformatics and data curation, and last but not least, regulatory and writing. And here on the right, you can see a quite exhaustive list of type of activities that EPTRI could perform and support within a research consortium. They span across from the identification and characterization of biomarkers in pediatric samples, access to deposit of annotated biological samples, of course, pediatrics, bioinformatics, support to large-scale cohort screening, including neonates, infants, children, and adolescents, of course, in collaboration with large pediatric clinical centers, using biomarkers together with PK/PD modeling and simulation to support study design, optimization, and dosing algorithms, digital technologies and evaluation of biomarkers using advanced statistical and computational tools, delivery of novel point-of-care testing, use of biomarkers as for diagnostic and prognostic purposes for prediction of treatment response, systematic review of clinically relevant differences between adults and pediatric conditions using computational tools, and monitoring changes of marker of oxidative stress using wearable devices. The last 2 topics deals with regulatory qualification process of pediatric biomarkers and also networking activities in close contact with patient association and IPACs that could support age-tailored training and empowerment approaches starting from early childhood. And with this next slide, I would like to thank you for your attention. And if you want to know further, here you can see a list of relevant references. And that's all.
Thank you very much. Yeah.
Thanks to you.
Thank you. I'd like to call then Dr. Nadine to the stage, please.
Thank you for introduction. And welcome to my talk today. I want to talk about high-speed race, an analytical platform for high-speed cohort screening using Raman-enhanced cell analysis. I'm Nadine from the Laser Institute von Fraunhofer in Aachen. Next slide, please. What the challenges objectives we are looking at is the development of individually tailored therapies. As a basis, coming from the call is that we need new biomarkers to identify in an early stage the disease and to develop therapies for the prevention. We want to assess a better individual prognosis and test the therapies early. For that, we provide a technology which allows for miniaturization of the screening to allowing the analysis of large cohorts of samples. As we have already heard, liver cancer might be such an area, but our technology is free in the application. So the solution we want to provide with our technology is that we can reduce the needed sample volume, and by providing new chip designs with very small reaction chambers. Those chambers should be handled in an automated process for preparation and handling, and the analysis should be done by using AI technologies and deep learning algorithms. Using those new biomarkers will then be used for the development of organ-on-a-chip models and to develop new therapies. The platform is designed that it allows for standardization and broad applications. Next slide, please. We are focusing in 3 activities right now. First is the assay development. So we want to design new chips for parallelization in the micrometer scale and use therefore laser-based structuring of glass slides, for example. The process automation is done that we develop a new machine concept with laser-based sample preparation and Raman analysis, and of course, fluorescent microscopy. The models we developed are based on organ-on-a-chip systems, developing on the disease model we are looking at. And with these models, we want to evaluate new therapies for the future. Next slide, please. The expertise from the 3 partners we are discussing at the moment is coming from the Fraunhofer Institute ILT, with expertise in laser-based cell sorting, process automation, and development of new machine concepts. The company LPKF, which is a large company and is very expertised with high-quality glass tailoring and the development of high-resolution nanowells in glass and machine development. And the NMI Institute in Tübingen, responsible for development of assays, miniaturization automation of immunoassays, high-content protein profiling, and the development of new disease models, and so on. Next slide, please. Since we are still a very large consortium, we are looking for many partners and hope our technology is interesting for you. So we are looking for experts for biomarkers, for companies with expertise in digital analysis, assay development. Here we bring some information with us. Regulation and provision of patient samples would be interesting for our consortium. And yes, thank you very much for your attention, and thanks to the organizers.
Thank you very much, Nadine, for your presentation. I'd like to call on Thomas Endel to our virtual stage.
Hi there. So, hi. I'm going to pitch on the German national cohort, or NARCO study, as we like to call it, as a resource for health data and biosamples. And my name is Thomas Endel. I'm working at the Helmholtz Munich, which is one of the academic institutions conducting the NARCO study. Next slide, please. The challenge is, I think, apparent. For any type of biomarker identification or validation, you require high quality data or high quality standardized biosamples. And we think that both can be provided by the German national cohort. It's a population-based prospective study conducting a large amount of examinations in the broad population, general population, and conducting sample collection in huge amounts. So we have 200,000 participants enrolled in the study, and we're collecting a broad range of biosamples from blood fractions over DNA, saliva, stool, and urine. And the study is carried out by a large academic network, which I'm going to talk about on the next slide, please. So what we're basically doing is we are running 18 study centers across Germany, some more rural, some more urban. And we invite participants to come to the study center and answer tons of questions and questionnaires on, for example, mental health and their family history of diseases. And we collect biomarkers, which are then stored centrally at this neat little building to the right of this map at our center here in Munich. Next slide, please. And this is where we stand. So we started out in 2014. We conducted the baseline enrollment into the study between 2014 and 2019. We're now in the middle of the first re-examination, which is supposed to end about 2023. And then we are happy enough to we have gathered the funding for the next round of re-examinations until the year 2028. And in parallel, we conduct questionnaire-based assessments, validation by general practitioner contacts, but also by collecting health insurance data from all our participants and by doing a comprehensive mortality follow-up, which complements the data set that we gather together in the study centers. Next slide, please. This is the network of academic partners. Next slide, please. And in a nutshell, we can say that this is the largest health study going on in Germany right now. We have this comprehensive, huge biosample collection. Importantly, all the samples have been collected partly before, partly after the onset of the pandemic. So we have basically from every participant, we have data from prior to the pandemic to post-pandemic or during the pandemic. Next slide, please. And of course, as while the participants age and the cohort matures, people develop diseases. We're not focused to any type of disease. We're trying to be representative, but we also then gather diseases. So like 18,000 cancer participants, like 14,000 diabetics, and so on. And I think we'll be able to provide data and samples to any type of project that can use that in the while finding biomarkers or disease targets or validating them. Next slide, please. And so this is what we're offering. Basically, we can offer access to the data collection and to the sample collection. And also we could engage any of the 27 academic partners with their specific expertises. Next slide, please. But what we're lacking is actually funding for all types of omics analyses, from whole genome sequencing over metabolomics, RNA sequencing, proteomics, whatever comes to mind. So we started projects with smaller sample sizes, like 10,000 participants or so. But on the large scale, this is still something that needs to be arranged. And so we think that this could be of mutual benefit in any type of biomarker-driven projects. And that's my last slide, I think.
Great. Thank you very much, Thomas, for your presentation. And our next speaker is Rachel.
Hi, it's Rachel Steek here. I'm really happy to present today. So I'm here representing EBISC. We are the European Bank for Induced Pluripotent Stem Cells, and we are a centralized non-profit repository for iPSCs, working to support and simplify access to IPS for use within research activities. Various different ways of contacting me, and please just feel free to reach out. Yeah, next slide, please. So we are a research partner looking for consortia, and we have a lot of expertise and experience in working with different research projects in a range of different areas and applications. So despite the fact that IPS have been around for now 15 years, and they have been used in many different ways for disease modeling, screening, and biomarker development, there are still many problems which persist in their use, which we can support. So it can take a lot of time to generate new lines. Undetected quality issues lead to wasted investment of time and money. The actual generation, qualification, distribution of lines can be extremely time and resource intensive. Accessing lines on an individual basis, so on a one-to-one from the actual generating source, can lead to a lot of MTA negotiations and time wasted. And most importantly, knowledge of the provenance of the iPSCs, including the disease background, the therapy responsiveness of the donor, genomics of the donor, is really essential to improve understanding of disease pathology and to allow really full disease modeling and for their use in screening platforms. But typically, poor or limited data management applications leads to low traceability of where the line has come from, how it was generated, all of which impact the effectiveness of disease research. Next slide, please. So here, EBIS can really offer a range of different tools, services, and expertise to help tackle these issues. So we have access to around 900 IPS, actually probably more than that now, because we have new lines and cohorts coming all the time. And we cover around 35 different diseases, including neurological, neurodegenerative, diabetes, heart disease, amongst many, many others. We can also provide pre-differentiated cell populations across multiple lineages, including neural, cardiac, hepatic. And we can provide these in both high volume and low volume. So we have knowledge of upscaling and both miniaturization. And we also have a robust framework for ethical and legal governance and data management, which can be shared with research projects to avoid these common issues which typically happen. We also have a robust infrastructure for IPS culture, and we have multiple sites, all of which operate under a cohesive quality management system. This also includes a mirror bank for cross-site storage. We can support research projects directly by safeguarding lines and data, distributing cell material internationally, advising on and performing QC, and using protocols for IPS generation, gene editing, differentiation, and QC. We have also a lot of experience in translating third-party protocols to upscaled versions for rapid and cost-efficient cell production, all of which has come out of the current project phase that we are under at the moment with IMI and FPA. Last slide, please. In summary, we have done a range of different collaborations with different research projects, all of whom are using iPSCs across different applications, and we can apply this expertise to support other research projects. We can help to develop and provide tools such as pre-differentiated cells in a variety of formats. We can support with both sample collection and data management. We have a broad network of IPS research centers, both non-profit and for-profit, and we can help to engage with our research network and support researchers in a range of different mechanisms. We have experience working with cell depositors and users globally. So if you are working within an international consortia, we are really well placed to support with distribution, which actually we have seen be an issue even between consortia partners. So never mind outside the consortia, but within the consortia, and we can help tackle those problems. And we are open to discussing multiple core topics. So if you have any queries at all, please feel free to get in touch, either by the marketplace or by my email address listed here. Thank you very much, IHI, for the opportunity to pitch today.
Thank you, Rachel. Thank you for your presentation. I'd like then ask the next speaker, Antti, to join us on our virtual stage.
Hello, thank you for introduction. I'm going to present you Collaborate Health Cloud. So next slide, please. It is well known that data has yet to be leveraged, and this fact is based on the extreme growth in health data and the increased number of digital health apps. Consequently, healthcare expenditure per capita is raised, although premature deaths from chronic diseases stay stable. Next slide, please. But what has really transpired with health data is a need for more alignment, scalability, and coordination. As a result, developing correlations and suggestions is excessively time-consuming and has minimal impact. Next slide, please. Under these circumstances, Collaborate Health Cloud developed a new unified platform based on the occurring need for AI-powered end-to-end data solutions and health analytics. Next slide, please. Well, Collaborate Health Cloud is a specialized clinical application and analytics platform for holistic patient care in the prevention, management, and treatment of patients with chronic diseases. Next slide, please. Next slide, thank you. Not only is it an intuitive patient management and risk stratification tool, but it also operates as a care plan task management application. Well, the platform functionalities support healthcare practitioners in recording patients' health data concisely. Next slide, please. And now one more, if it's possible. So except for them, at the same time, the platform is a patient-provider communication tool, facilitating patient guidance support monitoring, and follow-up. Next slide, please. So once again, this is Collaborate Health is a patient-provider communication tool, as I said, for guidance, support, monitoring, and follow-up. Last but not least, healthcare professionals can seamlessly collaborate with peers to facilitate team-based clinical reasoning through the collective insight that leads to informed decision. Next slide, please. So Collaborate Health Cloud, thank you. Collaborate Health Cloud can easily retrieve medical, clinical, lifestyle, and health conditions data by utilizing data collection from wearables, specialized multi-omics diagnostics, as well as medical data from electronic healthcare records documented by healthcare practitioners. Additional patients can share real-time feedback, information, or data and insights for their health conditions. And our recent focus is the collection of multi-omics and DNA specialized exam. Next slide, please. But eventually, how can our platform contribute to a consortium? Collaborate Health Cloud's technology contributes to facilitating the scientific community to, 1, collect data using app interconnection with specialized diagnostic systems and wearable. 2, to store and organize precise data. 3, to aggregate biomarkers data and support the investigation of their effect on the development of chronic diseases. 4, to analyze the expert reports. 5, to proceed with comprehensive biomarkers interpretation. And last but not least, to correlate biomarkers with a prediction of specific diseases. The aforementioned objectives are accomplished via our cloud-based platform that constantly syncs with sophisticated mobile apps for healthcare providers, scientists, and patients or non-patients. So next slide, please. So generally, we are interested in collaborating with partners who have the same interest in the frame that has been described, and of course, to join in a relevant consortium. Thank you very much for your attention.
Thank you very much for your presentation. So our next speaker, Arne, can you please join us on our virtual stage?
Hello, everybody. This is Arne Feist from 4D LifeTech. We are a Swiss company specialized in the development of early cancer detection biomarkers and working and integrating those biomarkers into our existing high throughput assay platform and workflow. I'm pitching on one of those applications, which is possible because one of the things which still limiting good cancer treatments is that we are not able to have high sensitivities in early cancer, which would open the door to screening. Next slide, please. So if we look into the cancer diagnosis of today, we still have certain challenges. One is the cancer burden, and this is an example of lung, but it's worthwhile for all kinds of cancer. And one of the main things which we are lacking is that we have no early detection, as I said. So late diagnosis equals today poor prognosis for effective treatment. If you look into the diagnosis itself, most of the diagnosis ends up very fast in highly invasive treatments and on solid tumors. So that's why liquid biopsy has been introduced a while ago. To get a less invasive approach to that. However, the genomic assays currently proposed to the market have still low sensitivity in early stages, high specificity but low sensitivity. And then, of course, you have burdensome confirmation assays at the end. And of course, if we go to asymptomatic patients in the early stage, we also have a cost issue if you would like to screen populations instead of people which are already affected by cancer. However, and you see that below, if we could increase the survival rate, the diagnosis outcome, the positive outcome and the sensitivity to earlier stages, we would probably be able to really also increase the 5-year survival rate massively and decharge the healthcare system from treatments afterwards. Next slide, please. That's the reason why we are currently running a project to develop complementary early cancer diagnosis, because we believe that early detection of cancer is early end detection of cancer. Both seems to be very complicated. And we could contribute with our biomarker to the early detection, to the really screening, which is mentioned here as liquid biopsy 1. The marker is a transformational biomarker. It's a completely new transformational biomarker, which is integrated in a very cost-effective, high-throughput technological platform, and which could really lead in early stages for the pre-selection of patients in asymptomatic stages. Of course, if you have a negative result, which will be probably 99% of the cases would be the case, we are proposing to have e-health in the back. So we need a wide data platform or a data warehouse, because that would be the first data platform comprising all asymptomatic data. So we could have generate out of these data, we could generate really a know-how about when and why affection takes place, which would open then really doors to prevention and prediction, because it would give us answers on what kind of factors are really transforming benign structures into malignant structures. And in case of having positive results, of course, we need more clarification on the genomic profiling of the kind of cancer, which would be guaranteed in this workflow to be at an early stage, and we would guarantee then to have, or we would try to get earlier inventions made possible to the patients. Combining these or implementing these workflow, we are currently working on a wider study proposal. The biomarker we have in hands is already has shown clinical evidence and high sensitivity, over 95% for lung cancer, breast, prostate, and colon, and we are constantly extending the applications for other types of cancers. Target is to increase outcomes, patient burden decreasement, and of course, health budget efficiency, to prove health budget efficiency of the process. Next slide, please. As I said, we would bring in such kind of a cooperation, the early stage transformational biomarker and a cost-effective high throughput workflow and technology platform, which is already used in the market, but currently only as confirmatory biomarkers. All tests which I said, or the biomarker itself is CE IVD marked for lung, prostate, breast, and colon cancer, as said, and the application enlargement or enhancement is ongoing. The biomarker shows high sensitivity, over 95% in early stages. It's very cancer specific. It's not able to detect the cancer itself. So that's really the reason why we would propose to complementing it with genomic tests in particular, to guarantee that these tests are given in early stages, while they are currently showing that in stage 1 and stage 2, they have very poor sensitivities. And for the technology platform, we have already discussed the potential partnership with Higasio. I don't go into details here because Dominic from Higasio will present later. And of course, we are looking for further tool tests, activities, exposure analysis, and so on. As I said, we are Swiss-based, so we are not absorbing any EU funding because that's guaranteed by the Swiss government. Next slide, please. So we are looking for partners, pharma diagnostics, medtechs, also CROs and HC providers. We have a lot of clinics already in the network, but we are still looking to extend that. And we could also involve payers. The industrial consortium, which would contribute here, or which would integrate the interest to identify patients earlier, would be requiring a coordinator, and then industrial or academic partners with experience on genomic liquid biopsy tests, lab study design management, HTA, data and finance, and so on. And of course, options to be included would be further cancer types, which we can elaborate during this cooperation, additional diagnostics modalities in setting up the workflow, or also devices, and then early invention and prevention. But behavioral, but also medical wise, for using the database. So get in contact with me. All my data are available, or contact me directly on the company's homepage. You will find all the data. Thank you very much.
Great. Thank you, Arne, for your presentation. And our next speaker, Miroslav.
Yes, hello. I'm Miroslav. From Glycanostics. We challenge and improve early-stage cancer diagnostics. The Mind the Gap project will address the gap of false positive and false negative results of state-of-the-art methods for early-stage cancer diagnostics. The company is a spin-off from Slovak Academy of Sciences. It has secured private investments reaching 1 million euros, and we won IHI Accelerator project for our second opinion test for prostate cancer. Our ultimate objective is to diagnose cancer earlier and more accurately. Thus, we can save lives and healthcare system resources. Next slide, please. Glycanostics has invented and developed in a clinically validating a novel, affordable, non-invasive next-generation liquid biopsy cancer diagnostic test with a final accuracy of up to 90%. The approach for analysis of glycans as cancer biomarkers is unique from worldwide perspective, since we are the only company focusing on the use of glycans as cancer biomarkers. We can address prostate, breast, lung, pancreatic, colorectal, bladder, thyroid, ovarian, testicular, liver, and stomach cancer. In the project Mind the Gap, we want to advance early screening and second opinion diagnostics of some of the cancer indications mentioned above, thanks to a combination with other serum biomarkers. Next slide, please. So we want to advance the breast cancer screening method in combination with other serum biomarkers of different origin, for instance, proteins, DNA, RNA, or some other indications. We want to develop a massive screening diagnostic test for pancreatic and lung cancer indications. And we want to identify novel biomarkers, preferably tissue-specific, for other cancer indications suitable for massive cancer screening and second opinion tests. Next slide, please. So what we bring to consortium, we bring the proprietary IP technology and know-how, which is patented. We bring in strong scientific background in the area of biomarker discovery and assay development. We bring in state-of-the-art R&D infrastructure in Bratislava, Slovakia, and also the project coordination and management skills, including project writing. The team has extensive experience in R&D projects. The founder was funded by ERC grant, and as I mentioned earlier, we won the Horizon Europe IHI Accelerator project. As a private company, invested private company, we have the business drive that we found very useful for this kind of project. Next slide, please. We want to complement the skill set of glycanostics, and the partnerships we are looking for come from protein, RNA, DNA biomarkers for indications presented above, clinical institutions for clinical validations of the biomarkers, clinical institutions to launch of the diagnostic tests across the EU, magnetic nanoparticle synthesis, or protein labeling protocols. These can come from any type of institution which is eligible for the project, and we are specifically looking for industrial partners who can co-fund the project. Thank you very much.
Thank you very much, Miroslav, for your presentation. Our next speaker is Jan.
Yes, hello. I would like to introduce everybody to the personalized diagnostics for oncology that we're working on. First indication is hard to treat lung cancers. Next slide, please. So in the green, you can see what is the patient urgency for immunotherapy. We see that the durable response rate is around 20% of these very expensive treatments. And beyond the fact that quite a lot of the medication that is provided basically has no use because it doesn't work for the particular patient, it also leads to a lot of bad adverse effects because of the fact of the side effects. So basically what we are trying to do is increase the quality of life, expansion of lifespan, and potential recovery of these late-stage lung cancer patients. Next slide, please. So we have a basic workflow in place, and we need to do some more development in other places. So we know how to clarify molecular signature of complex tumors of patients. It's a combination of really wet lab activities that we do by looking at tissue and doing multi-omics analysis and bioinformatics and AI. Through that, we determine the active pathway in a tumor, test the drugs on patient material, and then we come back to a treating physician with a treatment option. And once we have a fully validated workflow, what we will do is we will be able to apply that to all oncology indication where a patient biopsy can be obtained. Next slide, please. So this is in a picture. So on the left, you see a tissue picture. What we do is in those very heterogeneous tumors is we cut those up in specific subgroups of cells and do a separate analysis on those groups of cells. So we have a number of issues of downstream analysis listed here. So we do transcriptomics, we do proteomics, we do mRNA and microRNA analysis. And underneath you see the consortium at this point in time, consisting of our company, obviously, but also academic partners and a number of SMEs. Next slide, please. So we offer the clinical expertise, selecting the subsets of cells, which is very crucial in this whole issue because, let's say, the heterogeneous tumor material does not allow very clear picture of what's actually going on a molecular basis. Then we provide the data sets and we identify potential drug candidates. And ultimately, we test out the best candidates on patient cells and provide the treating physician with a treatment recommendation. Next slide, please. Okay, we are looking for specific expertise. Obviously, we're also looking for parties that can co-fund with us. So we're looking for corporates with strong clinical oncology product background. Both for expertise in the commercial clinical setting, but also for funding. We're looking for patient organizations for the patient view on PDL and potential funding, and other supporters and visionaries. And I must say, thank you, IHI, for having us present here, but also looking at all the presentations, I see a lot of opportunities for collaboration here. So thank you very much.
Thank you very much, Jan, for your presentation. Our next speaker on our virtual stage is Marco.
Yes, good afternoon. My name is Marco de Boer. I'm the CEO of Predica Diagnostics, and we are developing an exciting novel technology to measure RNA levels in cells. And we use that for the early detection, screening, and precision medicine of cancer. Next slide, please. I think, like previous presenters already mentioned, it is really important that cancer is diagnosed at an early stage. For example, the general outcome when cancer is diagnosed late is only 21%. And this can really increase if there's an early diagnosis. You can increase patient outcome to almost 90%. So early diagnostics is key. And another point is that roughly $40 billion are spent on cancer drugs yearly. And well, there are large groups of cancer patients that receive the wrong treatment due to the lack of reliable companion diagnostics. So I think the main message, of course, is that early detection is key to prevent cancer, and we need personalized diagnostics for the right treatment. Next slide, please. And I think that nowadays with whole genome sequencing, we are taking a big step. So we now know which mutations are causing specific cancers, but I think it's now the time to also include the gene expression profiles of tumors. because we really need to know which genes are expressed in order to have the right treatment. So we need to go from genomics to phenomics. Next slide, please. And I think that's where our technology comes in place. So we have developed a high throughput RNA sequencing technology. So what we have done is that we have developed hundreds of probes that can target pathways that are involved in cancer. And we use these probes in combination with next generation sequencing to get gene expression profiles. And based on these gene expression profiles in combination with artificial intelligence, we can have an early detection of cancer, and we can also predict effective and personalized treatment. Next slide, please. So far, we have shown proof of concept of our technology for different types of cancer. Our main product is at cervical cancer prevention. So we have shown that our technology works in cervical smears, but we have also looked at prostate, renal, brain, and lung cancer in FFPE tissue and in cryopreserved tissue. And also cool thing is that we have shown that we can detect RNA in blood, and that will help us to find metastatic cancer. Next slide, please. So the use case for us is in cervical cancer screening. So what we have developed is a cervical DX test. And with this test, we can measure the RNA molecules that are present in a cervical smear that are derived from the HPV virus that can cause cervical cancer and from the genes that are expressed, so the oncogenes. And based on these gene expression profiles, we can predict the risk of cervical cancer, and we can also advise on proper treatment. So this is a use case that we have now published, and we have validated on hundreds of clinical samples. Next slide, please. So what we offer is that we have our technology, of course, for early screening of cancer, and we have solid collaborations on the basis of a Eurostars program with the Radboud University and the Charité. And we are looking for large companies and consortia that could use our technology, for example, in the field of diagnostics, high throughput screening, sequencing, and of course, we also are looking for the clinical samples. Next slide, please. So that's my final slide with my contact details. And of course, you can find me through the IHI call. Thanks a lot, organization, for the great opportunity here.
Thank you, Marco, for joining us. Our next speaker is Dominic.
Good afternoon. I'm representing Higiazo here. Higiazo is a startup which is bringing everyone's personal health data to their own device so they can decide what they share selectively with whom for what purpose. We're already active in one of prior projects in the domain of lung cancer, and that's why we here propose the seeding of another consortium focused on early lung cancer, depending on the size, possibly to be expanded for further cancer types. Next slide, please. So you've seen this graph before already, and evidently has been discussed already that most cancers are diagnosed at late stage, at which prognosis is very poor, in particular the case for lung cancer here. Whereas at early stage, stage 1, pre-symptomatic, often the shape is quite different, low frequency of diagnosis, but quite promising outcomes. So if we can shift that green curve, then we can, without changing the science or advancing in the science even, dramatically multiply the positive outcomes already. Let alone this could help to avoid some of the burdens on conformational procedures if a suspicion is raised at early stage, if those tests would only be more reliable, and it would allow to direct the health budget more efficiently to the patients that actually need it, as opposed to confirming the false positives to be in fact negative, i.e. benign. Next slide, please. So what we're asking for is a study, a comparative study to analyze various current practice and innovative tests and compare them complement them with additional markers, so be it exposure data or behavioral data that could help in the screening of lung cancer, bring in additional health data from existing sources, and also evaluate possible early interventions, be they preventive or early curative. If we do so, that will generate a lot of data around the today very scarce early lung cancer population and help better insights in that population and provide the evidence to choose the most appropriate method and approaches to screening of early lung cancers, with the obviously expected outcome that this is improving outcomes, reducing patient burden, and better allocating the health budget. Next slide. Higiasa as such, is indeed such a patient disease agnostic platform that allows to reach out to patients, exchange with them, enable the performance, distribution, collection of consumer testing, supporting that, hence supporting decentral trial and real-world data sourcing. It does specifically deal with the consenting bit, so obtaining a specific consent from a user to a particular use of the data and the sharing of that data, enabling the linking of data held in data sets already established on the basis of such subject consents, is indeed what we actually do. Now, in this consortium, we're proposing our contribution as one element of many, of which we have seen 4D LifeTech already pitching one of such possible tests that could indeed be included. We have seen other presentations already today that go into a similar direction. So open to include others. But foremost, next slide, what we are at this stage looking for are industry partners that are taking the lead, obviously based on a common interest that both pharma, diagnostics, and medtech share to identify early patients. But on a second thought, you already realize that also healthcare providers, research, and payer organizations also share that belief that early patient identification is key here. So we're looking for industry to step forward, take a lead in such a consortium that we are proposing. We are inviting coordinator and also other participants to join such an effort in the spirit of leveraging prior work of much of that directional work has already been happening in H2O, IDERA happening there, Eden or Optima, other IHI and IMA projects. So the intent is really to leverage that work in order to have a compounded impact there. Depending on the size of the consortium that we manage to congregate here, we could also consider expanding that to further cancer types, but that will obviously depend on the power of the consortium that we can assemble. So with that, I believe this is the last slide already, and I thank for the contribution and the opportunity to pitch and invite others to come forward and reach out. Thank you.
Thank you very much, Dominic, for your presentation. Nora, can I ask you to join our virtual stage?
Yes, of course. Hello, good afternoon. My name is Norberta, and today I'm presenting you a photo, first digital solution to detect frailty while it can still be reversed. Next slide, please. According to WHO, by 2050, the world's population aged 60 years and above will increase in half and will reach 2.1 billion of older adults. This, however, living longer doesn't necessarily mean living healthily and maintaining the same quality of life. Actually, quite the opposite. 50% of those individuals are 3 times more likely to experience falls and fractures, hospitalization, and premature mortality. Next slide, please. Current healthcare system cares about frailty only when it becomes symptomatic. Sometimes some of these patients are even already care dependent. producing significant costs for our healthcare system. With a Forto, we would be able to detect the declines in intrinsic capacity before they result in frailty. And we can do this with a Forto by monitoring the physical reserves of elderly individuals systematically. And these tests, next slide, please. Our Forto system, yeah, our Forto system is composed of 3 components: dynamometer, mobile application, and telemonitoring platform. The test goes by patient performing first maximum grip strength and then maximum effort tests, which are then compiled using our in-house developed algorithm and transmitted to mobile application and selectively to the telemonitoring platform. The patient and the healthcare professional in charge will then receive notifications in case any abnormal changes are visible. Next slide, please. Our main goal is to contribute to the healthcare system model shift from treating the symptoms to actually preventing from them happening in the first place. And this is especially important for us. We have combined a multidisciplinary team and worked in many different projects, some of them locally in Belgium and Netherlands. With our newest project, we are working with WHO in shifting this paradigm and working on several working groups that are working on developing certain guidelines to make this preventive model accurate. And here we would like to join different consortiums that would be interested in the same thing, that they would also be interested in addressing the needs of the fastest growing world's population, elderly. Next slide, please. What we can offer as UNIVEP, we can offer our Forto solution, which is an evidence-based scalable digital biomarker to monitor physical reserves, intrinsic capacity of elderly. We can also offer our online telemonitoring platform that produces clinical reporting and is interoperable with other systems. And we can also help to develop preventative care pathways, as we also have a lot of research institutions, but also hospitals and doctors interested in frailty to care for patients with age-related disorders. Next one, please. What we are looking for is the interdisciplinary collaboration with others who are interested in the same setting and would be interested in incorporating a Forto solution into either their existing or to be developed care pathways for elderly, and also long-lasting collaborations with other parties interested in developing preventative solutions. And additionally, we would be interested in establishing large-scale studies where Forto could be used to monitor patients' physical reserves to further refine our algorithm. Thank you so much for listening and have a good day.
Thank you, Norberta, for your presentation. And our next speaker, Ana Blanco Sanchez.
Yes, thank you. Good afternoon. My name is Ana Blanco, the Grants and Innovation Coordinator of Quibim. Quibim is a company designing and creating pioneering tools to unlock imaging data to maximize drug programs and improve patient outcomes. Our company also follows an artificial intelligence first approach to help detect the pathologies and predict outcomes in oncology, immunotherapy, rheumatology, and neurology mainly, using different imaging modalities such as MRI, CT, and PET. The goal of the company is to transform imaging into actionable prediction, developing mainly novel quantitative imaging biomarkers to deeply analyze disease mechanisms, advancing in drug discovery and monitoring treatment progress through the whole body approach. Next slide, please. The challenge and objective that we want to share with you to participate in a project as a coordinator, as a partner, is increase the availability of validated biomarkers for disease interception and diagnostics tested mainly in real-world settings, and also to participate in advanced analytics and artificial intelligence supporting health research and innovation projects and real-world data, resulting in wider availability of personalized health intervention to end users. Also, researchers will have new biomarkers, mainly focusing in imaging prediction and prevention to the development of safer and more effective personalized intervention tailored to the individual's characteristics. Next slide, please. Our main activities is focusing radiomics, deep features, and deep learning-based tissue phenotyping. Also, we are involved in the identification of imaging biomarkers as surrogate endpoint outcomes for the different pathologies. Also, patient finding the real-world evidence analysis for synthetic control arms. Also, we are working in predictive artificial intelligence model generation. Also, we work with digital biomarkers and needed to be clear as a future companion diagnostics, and also the implementation and deployment of artificial intelligence machine learning tools. Next slides. Our expertise and resource offer gives us to become the leader of virtual biopsies at international level, using quantitative imaging biomarkers to unlock complex disease, as several partners are mentioned in the different topics of Code 3, signals in medical images, and building whole body imaging solutions for system biology. Our strategic lines and that we are working on is companion diagnostics for biopharma partners, world-leading algorithms for medical imaging hardware, and also a first workflow system for real-world evidence specialists. And finally, our main focus is biomarker discovery for research consortium. Next slides. We participate and we are involved in a network at the European level, for health imaging, regarding for all the group of the different H2020 projects and also Horizon Europe projects, such as PRIMATS, mainly focused in the pediatric cancer, PAINFAR, ProCancer Eye, mainly focusing in prostate cancer, CMELEON for the different pan-cancer lung, breast, prostate, colon, rectal repository at European level. Also ProCan-ID and DeepCan related to prostate cancer and metastatic cancer. Also RadioVal, that is from Horizon Europe, related to the neoadjuvant therapy in breast cancer. We are involved in FLUTE, which is federated learning multi-party computation for prostate cancer. And also we are having recently grant with the EUCAIM, which is the biggest European digital federated infrastructure of cancer images for the European Commission in the program Digital. So thank you very much for the IHI for the event, and thank you for your interest.
Thank you, Anna. Thank you very much for your presentation. And our next speaker is Malhar Patel.
Thank you. My name is Malhar Patel. I'm here representing Rhino Health and the Rhino Health platform. Our goal is to enable privacy-preserving data collaboration across life sciences, leveraging technologies such as edge computing and federated learning. Next slide, please. So there are several challenges in implementing AI in life sciences and making it of clinical value. It has great potential, but its impact is slowed by low generalizability. AI performance deteriorates when you apply it on new populations. Human bias is encoded in siloed training data, and that bias can be propagated to new populations. Next, high complexity and lack of an honest broker. Oh, sorry, previous slide. Lack of an honest broker make data collaborations difficult. And all of these challenges are particularly noted in Europe, where regulatory complexity increases barriers to collaboration. The Rhino Health platform decreases those barriers and facilitates projects. As I mentioned, it leverages edge computing to alleviate data sharing and instills trust among collaborators. Federated learning improves algorithm performance and generalizability, and the platform provides an end-to-end workflow for AI development through a robust MLOps feature set. We have already facilitated many large projects, including distributed computations and registries with the American College of Radiology, linking several cancer centers to use federated learning to improve the detection of pancreatic cancer on imaging with the National Cancer Institute, and then powering federated learning for medicine, the first hospital-based federated learning consortium, to translate AI into the clinic. Next slide, please. The main activities that we can provide to any group, the Rhino Health platform and Rhino Health is relevant for any project that would benefit from data sharing across multiple stakeholders without risking patient privacy. any project that needs robust end-to-end AI development tools, and then any project that considers clinical translation and commercialization across geographies, given the truly global footprint of the platform. Next slide, please. The expertise and resources offered by Rhino Health include the Rhino Health platform, which is accessible via easy-to-use GUI and SDK, project execution support such as installation of the platform, onboarding and training, and monitoring and maintenance of the platform. This also includes IT security clearance at each necessary hospital. And then on a case-by-case basis, resource dependent, we can also offer AI data science expertise. And then third, there are partnership opportunities. As I mentioned, we have a truly global network of hospitals and KOLs across several geographies, including Israel, the UK, the EU, and the US. Next slide, please. We are looking to join a consortium. Specifically, we're looking for large companies in biopharma that are interested in pursuing a project with high clinical and business impact and who dare to operate on the cutting edge and push the field of healthcare AI further. We're looking for research institutes and hospitals that want to use their underlying diverse patient data to unlock innovation and who are also committed to preserving patient privacy. And then finally, SMEs that have expertise or interest in healthcare AI and data science. And as I mentioned, if necessary, we can also bring that to the table.
Great.
Next slide, please. Yeah, thank you.
That's your final slide, yeah. So thank you very much, Malyar, for your presentation. So this was our last presenter for this session. Here's the list of presenters. Just wanted to remind you how to contact them. You can either click on the pictures call session 3 on the top navigation menu, or if you go also to the agenda, you'll be able to find the list of the pictures with the topics of their presentations. And just below you have the list of speakers. So all the presentations and the recordings will be available at IHI website. Thank you very much for your attention. We look forward to having you at the next session.